All right, so here's what we had done so far. We said that the sine function is not one-to-one, so it does not have an inverse. So we decided we needed to limit its domain. So for the sine function, how did we limit its domain so we could talk about its inverse? Negative pi over 2 to pi over 2. And for the sine function, what is its range?
Negative 1 to 1.
Negative 1 to 1. Okay, so if we take the sine function and we limit its domain to be negative pi over 2 to pi over 2, we can then talk about an inverse sine function. For inverse sine, what would its domain be? What kind of numbers can you plug into inverse sine? Any numbers between negative 1 to 1, because the inverse function interchanges the x's and the y's. So the y's here become the x's there. And the range, what kind of y numbers will we get when we use arc sine? Negative pi over 2 to pi over 2. Okay, and then we did the same thing for cosine. Y equals cosine x. And over here we want to talk about cosine inverse. And we had the exact same problem. The exact same problem was the cosine function was not one-to-one. So we had to limit its domain. How did we limit the domain on the cosine function? That one had to be 0 to pi, because the cosine was positive in both quadrants 1 and 4. We couldn't use minus pi over 2 to pi over 2. All right, so for cosine, we have to limit between 0 and pi. Our range is the same, negative 1 to 1. So when we're dealing with arc cosine, we can plug in numbers between negative 1 and 1. And the y numbers we're going to get, oops, oh, that's right, are going to be between 0 and pi. All right, we didn't talk about this one yesterday, but we're going to talk about it today. What about the tangent function? Is the tangent function a one-to-one function?
No.
No. For example, there's a graph of the tangent function, and it is certainly not one-to-one. It does not pass the horizontal line test. How are we going to limit the domain for tangent?
Limit it from negative pi over 2 to pi over 2.
From negative pi over 2 to pi over 2. So this would be negative pi over 2. There's a vertical asymptote at negative pi over 2. And then there's a vertical asymptote at pi over 2. And that does give us one complete cycle of the tangent. So I think you're absolutely right. So for tangent, we're going to have negative pi over 2 less than x less than pi over 2. Notice I cannot have the equal. Can't see what I just wrote. I can't have the equal like I can for sine. For sine, I have the equal to's here. For tangent, I can't, because what happens when I try to put pi over 2 into tangent? I get an error. It's undefined because I have 0 down on bottom. All right, how about my range? What kind of y numbers do we have on this tangent function? All reals, because it's got an asymptote here at negative pi over 2, it goes down to negative infinity. It's got an asymptote at pi over 2, it goes to positive infinity, so it's all reals. So our y values are all reals, which I'm going to choose to write as negative infinity to infinity. All right, so when we talk about arctangent, tangent inverse of x, which is arctangent of x, our domain for arctangent, we can plug in any number in the world. Any number that we like at all. And the kind of answers we're going to get answers that are angles between minus pi over 2 and pi over 2. Questions on that? I did switch them, didn't I?
Yeah.
Yep, my x's here became my y's there, and my y's there, and my x's there. Absolutely, they should switch. All right, so here's the sort of problem you're going to see. We'll do lots of problems today. How about arc sine of a half? I'm going to that big chart that I memorized, and I'm looking for the sine row, and I'm looking for where sine is a half, and the right angle is pi over 6. How about arc sine of negative square root of 2 over 2? So again, I'm going to that big table, and I'm looking for the sine, I'm looking for square root of 2 over 2, and I see pi over 4. But what's that little minus sign inside there going to force me to do? What's that? The answer has to be negative. The answer has to be in quadrant number 4. So the answer has to be negative pi over 4.
It's in quadrant 4, you said?
It is in quadrant 4 because sine is negative in quadrant 4. Mm-hmm. It's also negative in quadrant 3. But remember, we picked our domain to be negative pi over 2 to pi over 2. So between negative pi over 2 and 0, that's down here, isn't it?
Yep.
Negative pi over 2 to 0. So we're down here in quadrant 4 when we're dealing with arc sine.
Okay.
All right, arc cosine. How about the arc cosine of a half? Again, I'm looking at that big chart in my mind. Pi over 3. Okay. How about the arc cosine of negative square root of 2 over 2? All right, so it's pi over 4. And we need to convert it to quadrant number 2. So the correct answer is 3 pi over 4. So I look on the big chart, and I see this square root of 2 over 2. On my chart, that tells me pi over 4. But because of this minus sign, I need to convert to quadrant number 2 because cosine is negative in quadrant 2. So basically, when you're dealing with arc cosine, when you have a negative, you're going to take pi minus whatever the answer is you get on that chart. So arc cosine is the hard one to deal with in that sense. And you combine your fractions, you get 3 pi over 4. Questions on that?
Do you have to convert tangent into quadrant 3?
No. For tangent, which quadrants are we using?
1 and 4.
1 and 4. So our tangent is fairly easy to deal with. If I give you arc tangent of the square root of 3, you're looking at your big chart, and you're going to tell me the answer is I'll give you a hint. It's got a pi over 3.
Yeah.
Okay. Make you sure. Pi over 3. However, if I give you a negative number, like arc tangent of negative 1, you look on your big chart for tangent. Where is tangent equal to 1? Pi over 4. But what's that minus sign tell you have to do? Put it in quadrant number 4. So how do you put it in quadrant number 4?
Take 2 pi minus.
You simply make it negative. Because again, in quadrant 4, we're choosing to write our angles as angles between negative pi over 2 and 0. We're choosing to write our angles as negative angles. So again, our tangent is easy. If you have a negative number here, you just make your answer negative there. That's all there is to it. Cosine is the only one that's a pain in the neck to deal with. Oh, they're all kind of a pain in the neck, but that one's the worst. All right, how about problems like this? What if I asked you for the cosine of the arc cosine of negative 1/2?
Start in the middle and work your way out.
Start in the middle and work your way out. That would be the hard way to do it. But it would be correct.
F of X, G of X.
It's one of those f of g of x things. That's correct. And what can you tell me about cosine and arc cosine?
Inverses.
They're inverses. So what happens when I have a function and its inverse? They simply cancel each other out, and the answer is negative 1/2. That's the easy way to do it. You simply say that cosine and arc cosine are inverses of each other. Since they are inverses, they reduce each other.
But if you have like sine of arc cosine is negative 1/2.
Ah, then you got a problem. All right, so let's do that one. What if you have sine of arc cosine of negative 1/2? Then I agree with you. Now, sine and arc cosine are not inverses of each other, so I can't just say cancel them out. I agree with you. Now I got to do the hard work. So now I start in the middle. I need to first find the arc cosine of negative 1/2. So I might come off to the side and write that down here. Arc cosine of negative 1/2. That's going to be pi minus something, because it's a negative right there, so I know I have to be in quadrant number 2.
Minus
I was 3.
Oh, I hear dissension.
I was 3. It's pi over 3. Right?
He said it with anger. I'm going to go with it. Pi over 3. So that's 2 pi over 3. Pi minus pi over 3 is 2 pi over 3. So this is now the sine of 2 pi over 3. What's the sine of 2 pi over 3? Where is 2 pi over 3? Which quadrant? Quadrant 2. So my answer is going to be positive. Sine is positive in quadrant 2. What's the sine of pi over 3? 2 pi over 3. Well, it's the same. What's the reference angle for 2 pi over 3? Pi over 3. So here's my reference angle still, pi over 3. So I go to my big chart. Sine of pi over 3 is square root of 3 over 2. And I'm in quadrant 2, so my answer is going to be positive, square root of 3 over 2. What's that? So pretty much it's just sine pi over 3. That's exactly correct. You don't like that one very much, did you?
Wait, can you go over that one again?
Can I go over that one again? Okay. Starting where?
Beginning.
Start at the beginning.
Yeah.
All right, in the beginning, I noticed that sine and arc cosine are not inverse functions, so I can't just cancel them out like I could up here. So then I start at the inside. I start with a negative 1/2, and I do the arc cosine. Since I have a negative here, I know with arc cosine my angle has to be in quadrant number 2. So I take pi minus, and I look up the 1/2 on the big chart, and I got pi over 3. Pi minus pi over 3 is 2 pi over 3. So what that means is I now have to find the sine of 2 pi over 3. 2 pi over 3 is in quadrant number 2. Sine is positive in quadrant 2, so I know my answer is going to be positive. Then I have to take 2 pi over 3, and I need to remember what its reference angle is. If I have a 3 on bottom, the reference angle is pi over 3. So I look at my big chart, and I look up sine of pi over 3, that's square root of 3 over 2. There's a lot going on in that one little problem, isn't there? You got to deal with quadrants and inverses, and then quadrants and referencing. Lots going on in one little problem. Lindsay.
How did you know it was in quadrant 2?
How did I know it was in quadrant 2? When I deal with arc cosine uses quadrant 1 and quadrant 2. Since this is a minus,
Why does it use quadrants 1 and 2?
why does it use quadrants 1 and 2? Because when we drew our cosine graph, we noticed that cosine had a cycle. Well, it didn't have a cycle, it had half a cycle. It had all of its y values between 0 and pi. So the angles So I want to use angles between 0 and pi. That's all of those angles. So 0 to pi over 2, that's quadrant 1. Pi over 2 to pi, that puts me in quadrant number 2. Oops, and again I'm drawing stuff and you can't see it because I didn't switch the button back. There we go. So 0 to pi over 2 is quadrant 1. Pi over 2 to pi is quadrant 2. All right, how about the sine of the arc sine of -3? -3 seems like a reasonable answer.
Do they not cancel each other?
Unfortunately incorrect. Seems like they should just cancel each other out, doesn't it?
Should you just work?
I got a sine, I got an arc sine, they ought to cancel out. I should be able to just write -3. Just like I did up here. Up here I had a cosine and an arc cosine. I said just cancel them out. You're getting closer. It doesn't have anything to do with the negative. I could put a positive here and my answer would be exactly the same. Problem is, can I take the number 3 and plug it into arc sine?
Oh, no, it's not.
It's not in the domain. I cannot plug the number 3 or the number -3 into arc sine.
So there's no answer.
So there's no answer. That's correct. The correct answer is undefined. I can't do that. I can only do that. What are the only kind of numbers I can plug in here? Between -1 and +1. If I put a number there that's not between -1 and +1, I simply can't do it. So it's a trick question. The answer is undefined. That's mean, huh? Throwing trick questions in there.
Actually, do that for the test. That'll be easy.
Do that on. It's easy if you remember. It's hard if you don't. All right, let's do another one where these things don't match up here. So how about the cosine of the arc tangent of, give me a number.
One half.
I'm not real excited about the number 1/2. Why not? Because I looked at my tangent chart. Does 1/2 show up anywhere in that row for tangent? No, it doesn't.
Root 3.
Root 3, all right, root 3 shows up there. Okay, so once again, these are not inverses, cosine and arctangent, so I got to work outside in. So I start with the square root of 3 and I take the arctangent. What is the arctangent of the square root of 3?
Pi over 3. Pi over 3.
Pi over 3. And then I simply have to do the cosine of the pi over 3. It already is a reference angle, isn't it? I don't have to worry about reference angles. That was nice. Cosine of pi over 3 is
1/2.
1/2. All right. Let's make it harder. Cosine of the arctangent of 1/2. I didn't say we couldn't do it. I just said it's harder. All right, so the first problem is I look on that chart and I look for tangent being 1/2 and I don't see that on the chart. So this is not one of our special fancy angles that we know. So here's what we're going to do. What happens when I do arctangent? What kind of answer do I get?
An angle.
I get an angle. So this arctangent of 1/2 is some sort of angle theta, isn't it?
26.
It's what?
26.
It's approximately 26.6. Is that radians or degrees? Degrees, that's correct. It's approximately 26.6. I don't care, it's approximately 26.6. It's some angle. It's an angle. What I'm going to do is I'm going to take this equation and I'm going to do tangent on both sides. So what happens on the left-hand side? What happens when I do a tangent and an arc tangent? They cancel, so that's a 1/2. And over here, I just have tangent of theta. Okay, so now I'm going to draw myself a picture. Here's my angle theta. If tangent of theta is 1/2, how would I label that triangle? Opposite is 1, adjacent is 2. I go talk to Pythagoras. Square root of bigger than 3, because I would square this one, square that one, and then I would have to add them together. Square root of 5. Square root of 5. All right, so look what I have now. I have cosine of arc tangent of 1/2. The arc tangent of 1/2, we called that angle theta. So what I'm asking you to do now is find the cosine of theta. When I look, cosine of theta is 2 over the square root of 5. Questions on that one? Not too bad. Want to make it worse?
No.
No? Too bad. Let's do another one. All right. So which function do you want me to start with? Sine, cosine, tangent? I heard tangent first. Tangent of arc sine of what? I can't use 10 over 3. How come I can't use 10 over 3? It would be undefined. It would be a very easy answer. How about 3 over 10? 3 over 10 I can use. I can use any number between -1 and +1. I'm going to use 3 over 10. All right. 3 over 10, is that one of the special things on our row? No, absolutely not. All right, so it's the same sort of trick. When I do the arc sine of 3 over 10, I don't know what that is, but I know it's an angle. And then I want to get rid of the arc sine. How do I get rid of arc sine? Do sine on both sides. So that gives me 3 over 10 is the sine of theta. I draw myself a triangle. There's theta. How would I label this triangle? Opposite is 3. Hypotenuse is 10. Pythagorean theorem, I'm going to have 10 squared minus 3 squared. So that's 10 squared is 100, minus 3 squared is 9. That's square root of 91. All right, so all I need to do now is come back here and do the tangent of that angle theta. 3 over square root of 91, correct. Questions on that one? All right, last one I have that I'm going to give you some problems to do. How about the sine of the arc cosine of x over 4. I don't even have to put a number there. I can put some letters in there. Make it even more exciting. X over 4. What would you do? That arc cosine thing, it's going to be an angle. It's going to be some angle theta. I'm going to do cosine on both sides, so I get cosine of theta is x over 4. So the fact that I have an x there really doesn't change much of anything. I'm just going to have x's in my answer, that's all. So this is x, and that's 4. Pythagorean theorem. It's going to be square root of something. Square root of what? Not 4 minus x. 4 squared minus x squared. All right, so I come back up here, and now I have to do the sign.
So root 16 minus x squared
Over 4, that's correct.
Could you just make that 4 minus x? Like, could you take square root of
All right, so that is an excellent question.
it?
Does the square root of 16 minus x squared equal 4 minus x? Yes or no?
No.
Now here, reluctant no's, because if the answer was yes, the teacher would have done that. Why not?
Minus, right?
What's the perfect square is this tiny at 16?
I have 2 correct answers. The big one has to do with the minus. Pick a nice number that you like for x. Anybody got a favorite number? 1. If I plug 1 in here, I get the square root of 15. If I plug 1 in here, I get 3. Does 3 equal the square root of 15? No. You can only simplify square roots like that when they're connected by multiply. That one I could say that one is 4x. But when they're connected by add or subtract, unfortunately you can't just do square roots of each one. It doesn't work. Okay?